For generations we've told a grand story, the story of everything. It begins with a single, hot, dense point, the Big Bang. This theory has been the foundation of modern cosmology for nearly a century. It explains the faint afterglow of creation and the expanding universe. The story describes a universe that built itself up piece by piece, from a hot soup of particles to the first atoms, then stars and galaxies. Our telescopes, peering back in time, seem to confirm this. Distant galaxies looked small and primitive, just as expected. The Big Bang model made predictions, and for decades, those predictions matched what we saw. It gave us a cosmic calendar, marking the universe's 13.8 billion-year history. But science is about questioning, not clinging to old tales. We built our theories on the best evidence we had. But what happens when a new tool lets us see further and clearer than ever before? What if it reveals things that don't fit the story? The universe, it turns out, might have a few surprises up its sleeve. And those surprises are challenging us to rethink the very beginning of its magnificent saga. The story of the cosmos is about to get a major rewrite. To see the universe's baby pictures, you need a special camera, the James Webb Space Telescope, or JWST. This engineering marvel was built to look back to the dawn of time, capturing faint ancient light from the first stars and galaxies. Its giant honeycombed mirror collects stretched infrared light invisible to our eyes. Webb's sunshield keeps it frigid, blocking heat that would blind its instruments. This telescope is our most powerful time machine yet. Astronomers expected to see the first glimmers of clumsy, small protogalaxies. The JWST was supposed to confirm that the universe assembled itself slowly, just as the Big Bang theory predicted. But science is full of surprises. The JWST has done more than fill in the blanks. It's begun to rewrite the story. From its outpost a million miles from Earth, it's sending back images that are as baffling as they are beautiful. The telescope is showing us things that, according to our theories, shouldn't exist. The early universe may have been far more complex than we ever imagined. Imagine expecting newborns but finding fully grown adults instead. That's the shock astronomers felt when JWST's first deep-field images arrived. The telescope found galaxies just 500 million years after the Big Bang, an instant in cosmic terms. These galaxies should have been tiny and chaotic, but instead, they were massive, mature, and well-structured. Some even had spiral arms and central bars, features thought to take billions of years to form. The gas that formed these stars must have behaved differently, or star formation was far more rapid than we thought. The standard Big Bang model is gradual, but Webb is showing us galaxies that seem to have skipped steps. Some even contain supermassive black holes, which we thought came much later. The universe was in a hurry, building galactic metropolises almost overnight. This doesn't mean the Big Bang didn't happen, but it does mean a crucial chapter is wrong. The first few 100 million years must have been far more dynamic than we envisioned. Maybe the conditions were just right for rapid galaxy formation, or maybe something else was at play. These mature galaxies are a puzzle, forcing scientists back to the drawing board. The universe's early years are more mysterious than we ever guessed. Galaxies weren't the only things that appeared too big, too soon. In 2025, astronomers found a supermassive black hole, QS01, just 700 million years after the Big Bang. It weighs as much as 50 million suns, but has little galaxy around it. This challenges the idea that galaxies build black holes. What if it's the other way around? Stephen Hawking once proposed primordial black holes, formed in the chaos of the Big Bang itself. QS01's surroundings are chemically pristine, with no sign of heavier elements from star formation. This suggests QS01 wasn't born from stars, but as a seed that later gathered gas to form a galaxy. If primordial black holes exist, it would be a paradigm shift. Black holes could be the creative seeds from which galaxies grow. This would have profound implications for our understanding of cosmic evolution and physics. These ancient dark seeds might be the missing link explaining the universe's rapid growth. The early universe may have been shaped by black holes from the very start. The JWST's surprises didn't end with galaxies and black holes. In late 2025, scientists announced possible candidates for dark stars, objects powered not by fusion, but by dark matter annihilation. Dark matter is invisible, making up most of the universe's matter, but we only see its gravitational effects. The theory suggests that in the early universe, dark matter could have powered giant, luminous clouds of gas. JWST data revealed 4 objects, including JADE's GS-Z14-0, that fit the dark star profile. These giants could be 1,000,000 times more massive than our Sun. One even showed a spectral signature consistent with dark star models. If confirmed, this would be the first direct evidence of dark matter interacting with itself. However, the existence of dark stars is still debated. Some data suggests contamination from normal stars. Are these truly dark stars, or just unusual supermassive stars? Only more data will tell. The JWST's discoveries have ignited a crucial debate among astronomers and physicists. Some see these findings as a serious challenge to our current models. The discovery of primordial black holes could force a complete overhaul of how we think cosmic structures form. Others argue the core Big Bang theory is safe, but the details need refinement. The universe may have played the game faster and more efficiently than we predicted. Discoveries like dark stars and primordial black holes would ripple far beyond astronomy, impacting fundamental physics. These are not just curiosities, they're clues to the nature of reality. The debate is a sign of healthy science observation, hypothesis, and testing. The universe is challenging us to think bigger. Does this mean the Big Bang theory is wrong? For now, no. The core idea, that the universe began hot and dense then expanded, remains unchallenged. The problem is with the detailed timeline we built on top of it. Think of it like finding an ancient city where it shouldn't exist. It doesn't disprove the empire, but it forces a revision of history. Some scientists argue the Big Bang model just needs tweaks. Maybe the first stars were more massive, or galaxy formation was more efficient. Others suggest something fundamental is missing. Primordial black holes or dark stars could point to new physics. These discoveries suggest the seeds of cosmic structure weren't just gravity acting on normal matter. Black holes and dark matter may have played a leading role from the very beginning. This wouldn't kill the Big Bang, but it would transform it into a richer, stranger story. The darkness of the universe may have been just as creative as the light. The story of our origins is evolving. To understand the universe, you need a map. And Webb is the JWST's most ambitious project yet. It's the largest survey ever, mapping nearly 1,000,000 galaxies across 13 billion years. The project reveals the cosmic web filaments of galaxies and dark matter stretching across the void. Where filaments intersect, dense clusters form. Between them are vast cosmic voids. Webb provides visual confirmation of this structure, even in the universe's youth. The map reveals enormous structures, like the Sloan Great Wall. Studying these structures tests our theories of how the universe evolved. By analyzing the distribution of galaxies, we can measure the influence of dark matter and dark energy. The mature galaxies, primordial black holes, and dark stars are all points on this new map. Understanding their place in the cosmic web helps explain their origins. Webb is giving us the statistical backbone to decide if our theories need revision or revolution. Why care about galaxies billions of light years away or the universe's first second? Because these discoveries speak to our deepest impulse, to understand where we came from. The JWST is our most powerful tool for answering the big questions. These findings are exciting not because they prove us wrong, but because they show there's so much left to discover. Science is a dynamic, self-correcting process. When new evidence challenges a theory, it's a moment for celebration. The universe is more surprising and magnificent than we imagined. Competing ideas and debate are the engine of scientific progress. Over the coming years, astronomers will gather more data, test new ideas, and refine our cosmic story. This quest connects us all. The atoms in our bodies were forged in ancient stars. Understanding the birth of the first stars and galaxies is understanding our own origin story. The adventure of discovery is far from over. The universe is speaking, and we're finally listening.